Okay, so this video is on solving differential equations. Some of it is going to be a review for you. Some of it is going to be new. There is one tough question, but let's just talk about the basics. Solving a differential equation in the basic idea isn't really too bad. So let's look at this. We have y prime equals 2x over y. When you're solving a differential equation, you are going to want to make y prime into dy dx. So really I'm just going to rewrite this as dy dx equals 2x over y. So let's think about what we could do here, and feel free to jump in. What we could do here to solve this differential equation. Like, how would you solve this equation in normal life? We got two fractions equal to each other. Yes?
Implicit differential.
What's that?
Like implicit.
You would be kind of doing implicit backwards in that case, which you kind of are. But what you want to do is you actually want to cross multiply. Cross multiply? So if you cross multiply, you actually group the y's together and you group the x's together. So you have y dy equals 2x dx. This is the key. So if you're looking at what's in red, that's the key component, is to get the y's to one side and get the x's to the other. They call this a separable differential equation. That's the word. You can separate the x's from the y's. When you look at this right here, if you think about it, right, back in the day you were taught to add 2 to both sides, and that's how you solved an equation. And then one day they said, hey, you can actually square root both sides. And then they told you in pre-calculus, you can ln both sides if you want. Well, now we are going to integrate both sides. So we're just going to integrate both sides. And I'm not sure if this is a review or if this is really kind of brand new. Newish, pretty new. Okay. So when we look at this, you know, you may or may not have seen this, but we're really just using the same principles we've always used. This is our first issue, so we've got this. We've got to integrate both sides of this. So when we integrate this, it's easy. It's y squared over 2. We don't really need our plus c here yet, because we're going to put our plus c on the other side. So we're going to do this one. And that's going to be equals x squared plus c. So if you think about it, right, you could have put a c, I'm just going to do something quick here. You could have put like a c1 here and a k here or something just to differentiate. But if you move this over to here, they kind of wrap together and just become this one c. So you could have had like a plus c and then plus k for constant, and then move them together and they're just going to become another random number. So think about it. You got a random number plus a random number, or a random number minus a random number. At the end of the day, you just got a random number. So hopefully you understand we can just put one c there. And now what they usually are going to want you to do is to solve for y. You've technically solved the differential equations at this point, but they're usually going to say of the form y equals f of x. So what they want is, when they show you this on the AP Calc exam, they're saying you need to get y alone. The cool thing is the c you can kind of just ignore a lot. So you can multiply by 2. You don't have to make it 2c. You can make it y squared equals x squared plus c. And then let's see. I guess you would have to say y squared equals plus or minus the square root of x squared plus c. So that's how we're going to do that problem. I just want to verify that this is correct, so we'll pause for just a second. Oops. Okay, no. All right, so my students have graciously pointed out that my multiply by 2 on both sides, right, should have made this a 2x. We don't really need to make the 2 to the c because it's a random number. So if we multiply a random number by 2, it's still going to be okay. And then we have a 2 here, of course. And this is kind of going further than you need to. This is what we're going to eventually get to. Oops. But this is kind of where we want to be right now, just kind of getting this basic idea and integrating both sides and putting a plus c. So what I'll have you do is pause the video and give this problem a try. It's on page 382, number 5, and it should be on your handout. So good luck with that. Take a couple minutes. And correcting a once again, another mistake. Hooray for that. Should not be a y squared because we square rooted both sides. And that plus or minus, we're going to talk more about that in the future. It is important. We'll talk more about the c and like why we can multiply it by 2 and not change it and stuff. We're going to get into that soon. But what I want you to be understanding from this video is to separate, integrate both sides. That's the big thing. Okay, try that problem, which is right here. Good luck. So you want to check that in the back of the book. It isn't odd, and make sure that you got it. If you didn't, you might want to pause, reverse, check it out again. You can text me on Remind if you're in my class, or if you were watching this in some foreign country, you know, just find some resource. Okay, so our next example, this is kind of another straightforward example. I'm going to go a little bit faster on this. I'm going to go dy dx equals square root of x over 3y. But we're kind of getting the whole big idea is to cross multiply and then integrate both sides. You kind of want to get the y's all to the left usually, and the x's all to the right. And that's kind of like 9th grade, how we've always done it. Y equals mx plus b. And going a little faster because it's a pretty similar example. Integrate both sides, that's the big idea. So we got 3y squared over 2 equals, well, this is x to the 1/2. Okay, so we're going to have x to the 3/2 divided by 3/2. And that's really where we're going to get with this. Me personally, I like to at least get the y squared alone. And at some point, we're going to have to go further than this. But it seems that we're just kind of trying to get at the idea today, so we're not going to go too crazy. So 3y squared would equal, I'm multiplying both sides by 2, so I'm going to have 4/3 x to the 3/2 plus c. I'm not going to deal with the c. And then I'm going to divide by 3, so I'm going to have y squared equals 4 over 9, I'm dividing by 3, x to the 3/2 plus c. And that's probably a good place to be for these examples. So that's where we're at. So now we are going to take it up a notch. Okay. So now we're going to take it up a notch and watch or actually try an example that's a little tougher, uglier, not great, but we just got to get through it. So let's check it out. This one. So you see the stars. Stars in this course usually mean it's not a good thing. It's tough. Just look at the problem. Take a second. Think about what you might do. Maybe even pause the video and give it a go. Like try something. See if you get the first couple steps. All right, so hopefully you have tried this problem. The first thing, and I'm hoping that a lot of you just went ahead and subtracted x, y from both sides. So you now have dy dx. I'm going to go ahead and change that over to dy dx. We said that this is an ugly notation, like all class, but it's very useful. It's called Leibniz notation. And it was very helpful when we did related rates, and it's going to be very helpful for differential equations. But when we're doing regular stuff, we usually just try to stick to y prime. So here's where we're at. And we need to get the x's and the y's separated. So are there any thoughts on how we might proceed? Yes. So we will factor out an x. So if we take an x out, we have 100 minus y. And we're closer to getting them separated. We haven't really gotten there, but we're definitely closer. So let's see. We want the x's all on the right, so I'll move my dx over here. I'm kind of cross-multiplying, but not exactly. But I really don't want that 100 minus y there. I want the y's on the left side. So what will we do? How will we get rid of the 100 minus y? Yes. So we'll divide the 100 minus y. So if we divide that on both sides, we will have the following. So here's where we're at right now. Let's just take a moment. Let's breathe. We have dy over 100 minus y equals x dx. The big idea of this section is we can now integrate both sides. Yeah, the left side does not look great. The good news is the right side can be done pretty quick. So now the question is this, right here. The cool thing is we kind of have prepared ourselves pretty well for this in the last few sections. It's going to be a U-Substitution. It's going to be an ln type of thing. We would pick our U to be, let's see here. So let's just take a moment on this. Take some time. Our U will be the bottom, 100 minus y. That makes our du negative dy. And I'll put the negative over here instead. So that's where I'm at right now. So looking at that, if I was to rewrite that integral, now I still have an integral, but I have dy, which is negative du, so negative du, that's dy, over u. So I know that's going to be negative ln of the absolute value of u equals, and this is now integrated. So we've done all the hard work, and now it's a question of how much further do we have to go. Well, we definitely can't have a u there. And this is a little tougher than the examples you'll try tonight, so that's the good news. Probably going to want to isolate your ln, get that negative over to the other side. We don't have to make the c negative, so if we divide this on both sides, we now have a positive here, we have a negative there. And then to get rid of an ln, what do we do? Anybody remember? Yes, you exponentiate both sides. You make it to the, I'm going to make this e huge because people kind of are forgetting sometimes. So it's e to this power, and it's e to this power. All right? That's the main point. So let's go here. It's a little bit small, but e to the ln, now we just have the absolute value of 100 minus y equals negative x squared over 2 plus c. Oh, it's e to that. Okay. So I don't want you to worry so much about this right now. Let's just leave it alone. I will talk about this in a little while because it's going to make a plus or minus thing. It's going to be a little weird. But let's just not worry about it right now. Let's just talk about one thing that's important over here. When you have addition of exponents, if you think about reversing it, it came from e to the negative x squared over 2 times e to the c. And then say how if you would combine them, you'd keep the base and add the exponents. What I want you to know is that the book loves to make this e to the c just plain old c, because e to some number, e to the 7th, e to the 11th, is just some number. So what they're going to do is they're going to change e to the c to just c. So they're going to make it c e to the negative x squared over 2. And we're going to stop there. It's not quite the end of the problem, but I think that's a lot for you to take in. That's definitely a hard example. I'm not sure, and maybe number 9 is maybe that tough, but other than that, you shouldn't be faced with anything like that for a while. But this is a good example to revisit as we keep moving through the course on differential equations. So we'll stop the video there. Make sure you complete page 382, numbers 1 to 9. Good news is you already did number 5, so looks like you got 4 problems to do. We will see you soon.